Good morning students. Welcome to Natural Products class. This is Chandravati. In this class you are learning about forskoline. So you are learning about forskoline occurrence, uses, forskoline structural elucidation and forskoline synthesis. Forskoline occurrence and uses. It is isolated from Coleus forkoli. It is isolated from Coleus forkoli. The structure of forskoline contains 3 rings. So it is a tricyclic terpenoid, and on thermal decomposition it forms 4 isoprene units. So it is a diterpenoid. So forskoline is a tricyclic diterpenoid. It is an unique cardiotonic. That means it is used as drug for heart diseases. Also, it is used for weight loss. Structural elucidation of forskoline. Structural elucidation of forskoline. The structure of forskoline contains 3 rings. Let us name it as A, B, C. So the starting ring is denoted by A, and the middle ring is denoted by B, and the third ring is denoted by C. The overall structure of forskoline contains 3 hydroxy groups. 1, 2 and 3. So forskoline contains 3 hydroxy groups. Out of 3 hydroxy group, one is sterically hindered, and it contains one ketonic functional group and one acetoxy group, and it is also contain a carbon-carbon double bond. So it is a unsaturated compound. So finally forskoline contains 3 hydroxy group, 1 ketonic functional group, 1 acetoxy group and 1 double bond. The structure of forskoline is mainly determined by using spectral data. Its molecular formula is C22H34O. From C13 NMR data, it is a diterpenoid, and the double bond present in the forskoline is identified by reaction with Bayer's reagent and bromine water. That means on reaction with Bayer's reagent, forskoline forms a addition product. Similarly, on reaction with bromine water, it forms a addition product. So these reactions indicates the presence of double bond, carbon-carbon double bond, and the hydroxy groups at C1 and C6 are identified by acylation, but the third hydroxy group is not identified by acylation due to hindrance. The hydroxy group at C9 carbon does not undergo acylation due to steric hindrance. This hydroxy group is identified by using IR data, and also the carbonyl group at C11 is also not responded for 2,4-DNP reaction. That means the carbonyl group at C11 does not react with 2,4-dinitrophenylhydrazine, but it is identified by reaction with sodium borohydride. On reaction with sodium borohydride, the carbonyl group can be converted into secondary alcoholic group. So the carbonyl group present in the forskoline is identified as ketonic functional group. So on reduction with sodium borohydride, the carbonyl group in formalin can be converted into secondary alcohol. So it indicates the presence of ketonic functional group in formalin. Further, formalin on hydrolysis forms acetic acid. Formalin on hydrolysis forms 1 mole of acetic acid. So it have a acetoxy group. From this reaction, the formalin contains a acetoxy group. This is the structure of formalin determined by using spectral data, C13 NMR data and proton NMR data and IR data. So by using NMR and IR data, the structure of formalin is determined as this. So the structure was confirmed by synthesis. The next topic is synthesis of formalin. Formalin is synthesized from methyl vinyl ketone and methyl isobutanoate. So the starting material for formalin is methyl vinyl ketone and methyl isobutanoate. By using these two compounds, we can start the synthesis of formalin. The synthesis of formalin contains preparation of ring A and preparation of ring B, then preparation of ring C. Preparation of formalin contains construction of ring A and to this construction of ring B and construction of ring C. Ring A is prepared from methyl isobutanoate and ethyl vinyl ketone. When these two are condensed with LDA, lithium diisopropyl amide. Lithium diisopropyl is a base and it abstracts acidic proton from methyl isobutanoate and forms a carbanion. This carbanion attacks on vinyl carbon and forms a new bond with ethyl vinyl ketone, which on further reaction with lithium diisopropyl amide undergo cyclization by the loss of methanol to form a cyclic 6-membered diketone. So we prepared the ring A first. This ring A, the cyclic diketone, on tautomerization converted into enol form. This enol contains a hydroxy group. This hydroxy group is reactive group. So we must protect this hydroxy group. So this hydroxy group is protected by using benzoyl chloride. When this enol treated with benzoyl chloride, the hydroxy group is protected with benzoyl group. Our next aim is construction of ring B. For this purpose, the ketone, hydroxy protected ketone, is treated with Grignard reagent, especially vinyl magnesium bromide. So when this Grignard reagent is treated with this cyclic ketone. The vinyl carbanion from Grignard reagent attacks on carbonyl carbon and forms a new bond with this carbon, which on hydrolysis converted into a dihydroxy compound. So, which on hydrolysis, the benzyl protected hydroxy group and oxy magnesium bromide group both are hydrolyzed to form two free hydroxy groups. This dihydroxy compound on treatment with concentrated H2SO4 undergo dehydration to form a unsaturated ketone. So, by the loss of water molecule, the dihydroxy compound can be converted into a ketone. This compound contains two double bonds and a ketonic functional group. So, it is a dienone. It is a dienone. This dienone on reduction with sodium borohydride forms a secondary alcohol. This dienone on reduction with sodium borohydride, the ketonic functional group can be converted into a hydroxy group. This on reaction with fumaraldehyde, methyl fumarol undergo Diels-Alder reaction and forms a 6-membered ring B. So, the hydroxy compound on reaction with methyl fumarol undergo Diels-Alder reaction forms a 6-membered ring. At that time, by the loss of water molecule from carboxylic group and hydroxy group in dienol forms a lactone ring. So, in a single step, a 6-membered ring B and a lactone ring also formed. The formed new compound contains a double bond. This double bond on hydroboration undergo reduction, which on basic hydrolysis forms an alcohol. So, the product from Diels-Alder reaction is treated with borane in tetrahydrofuran followed by basic hydrolysis forms an alcohol. This alcohol on treatment with chromic oxide, the hydroxy group can be converted into carbonyl group. So, when this hydroxy compound is treated with chromic oxide, undergo oxidation to form carbonyl compound, which on heating undergo decarboxylation and dehydration, which on heating undergo decarboxylation and dehydration to form a new double bond. So, this compound on epoxidation with perbenzoic acid. When this compound is treated with perbenzoic acid, the double bond is breaked to form epoxide. So, On reaction with perbenzoic acid, the unsaturated compound forms an epoxide. This epoxide, on treatment with acid, converted to hydroxy group. This hydroxy compound, on treatment with sodium borohydride, undergo reduction and the carbonyl group can be converted into hydroxy group. So, the carbonyl group in the compound on reaction with sodium borohydride can be converted into hydroxy group. So, the product formed in this reaction contains two hydroxy groups on adjacent carbons. So, these hydroxy groups are very reactive. So, these are protected by using acetone. If two hydroxy groups are present on adjacent carbons and there is a need to protect that hydroxy group, then they are protected by using acetone. So, when treated with acetone, this compound, the hydroxy groups in this molecule are protected by formation of cyclic 5-membered ring. This protected compound on treatment with osmium tetroxide, the double bond can be oxidized to dihydroxy compound. This unsaturated hydroxy protected compound, when treated with osmium tetroxide, the double bond present in this compound is undergo oxidation to form a dihydroxy compound. Which on basic hydrolysis the lactone ring is breaked. Which on basic hydrolysis the lactone ring is breaked to form a free hydroxy group and free carboxylic group. To form a free hydroxy group and free carboxylic group. So, there is a need to protect the newly formed hydroxy group. So, to protect this hydroxy group, the compound is treated with TBDSCl, tetrabutyl dimethyl silyl chloride. It is a protecting reagent for hydroxy group. So, the product is treated with tetrabutyl dimethyl silyl chloride, TBDSCl. So, the hydroxy group is protected by TBDS. So, our next aim is to construct ring C. For this purpose, the compound is treated with organometallic compound, allyl lithium. It is treated with organometallic compound allyl lithium. From this, the allyl carbanion is formed and this carbanion is attacked on carbonyl carbon and forms a new bond with this, which on further reaction with vinyl copper lithium, another two carbon atoms are added to the side chain, which on treatment with acid undergo cyclization to construct ring C, which on cyclization undergo cyclization to construct ring C. Which on hydrolysis with potassium carbonate the protected hydroxy groups are converted into free hydroxy groups. So to remove the protection of hydroxy groups, the compound is treated with water in presence of potassium carbonate. So the hydroxy group's protection is removed and can be converted into free hydroxy group. So we done the synthesis of forskoline almost. There is a difference is acetoxy group in this. So to introduce acetoxy group, this compound is treated with acetic anhydride in tetrahydrofuran and dioxime at -78 degrees centigrade. Under these conditions, the acylation takes place especially at this carbon. So to introduce acetoxy group in forskoline, the compound is treated with acetic anhydride in dioxime and tetrahydrofuran is used as solvent, and this reaction is carried out at -78 degrees centigrade. As a result, forskoline is synthesized. This is the synthesis of forskoline.